On Mars, these features formed millions or even billions of years ago. They raise a tantalizing possibility. Both rovers will land in areas that might once have been lakes. Their mission is to learn more about the way water may have shaped the red planet. They may even find clues that will help future missions solve the biggest question. Has life in some form ever existed on Mars? First, the rovers need to get there. They must complete a dangerous trip through space of almost 300 million miles. The first 3 months of the journey to Mars goes as planned. Then, Mission Control receives some alarming news. Scientists at the U.S. Space Environment Center have just recorded a massive burst of solar radiation from the sun. A solar flare bigger than any witnessed in history is on its way toward the delicate probes. Solar storms are deadly. They can knock satellites back to Earth and even fry electrical grid systems.
The biggest solar flare in recorded history happened while we were on our way to Mars. It's just the kind of luck that we had with this mission. If there could be plagues of locusts in space, it would have happened to us.
The probes navigate by recognizing star patterns. Squires and his team fear that the bursts of solar radiation will be interpreted as stars by the probe's navigation system. This could be disastrous. The probes could go off course and never make their rendezvous with Mars. To solve this, the mission controllers switch to a backup navigation system that uses the sun itself. Their other worry is that the solar flare will damage the probe's computer memory. All the team can do is wait. After the storm has passed, the team reboot the computers to check for damage. To their enormous relief, the memory is intact. The probes have survived the biggest solar flare ever recorded.
It turns out that our spacecraft was more robust than most.
After almost 300 million hazardous miles, the first probe, Spirit, now faces the most dangerous part of the mission, landing. It's relying on yet another novel technology, airbags. These will envelop the whole craft and cushion its landing. Re-entry and landing is the shortest phase of the mission, yet a single failure, a single miscalculation, and the entire mission is a write-off.
You hit the top of the Martian atmosphere going 25 times the speed of sound. 6 minutes later, you're on the surface. It's a hell of a ride.
It's been called the 6 minutes of terror.
On January 25th, 2004, the spacecraft hits the Martian atmosphere 20 times faster than a speeding bullet. Rovers must contend with the harsh conditions of Mars, dust storms, rocks, and craters. Avoiding all this falls to rover driver Scott Maxwell.
I have the greatest job in two worlds. I come in every day and I look at pictures from another world that nobody's ever seen before. It's very much like a video game. And we have a 3D copy of the rover that we put down inside that video game, and we drive it around.
Every evening, the driving team uploads the commands for the day to the rover's onboard computers. The sun gets strong enough to power the rovers for just 4 hours every day. During that time, they can travel up to 330 feet. But mostly they don't travel that far. They find an area with interesting rocks and soil, then stay to explore. Cameras on board the rovers help them avoid obstacles like rocks and craters.
As they're driving along, they can take pictures of the world and reason about what's in it. They can figure out what the world looks like in 3D and find a safe path.
Only 8 days into the mission, Opportunity rover comes across some strange rocks. They are small and perfectly round. The team nicknamed them blueberries. On Earth, blueberry-shaped rocks normally only form in liquid water. Could these be proof that there was once a lake here? Geologist Marjorie Chan believes so. Before the mission even began, she had predicted that if water once existed on Mars, the probes might find formations of this kind.
When the rovers sent back those first images from Opportunity, we saw those balls and we just went crazy.
The team is delighted. The mission to search for signs of ancient water is bearing fruit. Then comes even more evidence. The rovers discovered two minerals, goethite and jarosite, which could only be formed in the presence of water. After 4 decades of looking, they now had hard evidence. Groundwater did once flow over Martian rocks.
Oh, I think the evidence is overwhelming that they have evidence for water on Mars.
On Earth, water means life. If there is still water flowing on Mars, who knows what future missions might find. But water alone is not enough to get life started. That requires a complex soup of organic chemicals as well. On Earth, life started just under 4 billion years ago. And since then, our planet has become a very different place. We can't go back in time to study the conditions on early Earth, but we can still study those conditions today on another world. In the early 1980s, the Voyager probes passed Saturn, taking the first close images of Titan, its largest moon. Measurements revealed that maybe Titan's thick orange atmosphere could contain the chemical precursors for life.
In some respects, Titan's atmosphere now is like Earth's atmosphere was perhaps 4 billion years ago.
Here, tantalizingly, sitting in our own solar system, was a moon very much like early Earth. But to see how life could have started, we have to go there. If landing on Mars was hard, landing on Titan could be impossible. Saturn's moon, Titan, is the only moon in our solar system with a planet-like atmosphere. But until 1980, no one knew what that atmosphere was made of. That changed when the Voyager 1 probe flew through the Saturn system and made an astounding discovery. Titan's atmosphere contained organic materials, a lot like the ones that eventually formed life on Earth. Could Titan be at the same stage in its life that Earth was around 4 billion years ago?
Going to Titan, in some respect, is like time travel.
But reaching Saturn's mysterious moon is a challenge far greater than any mission to Mars. Getting to the red planet takes 7 months. A mission to Saturn takes 7 years. And it must negotiate not only the asteroid belt, but the 165,000-mile obstacle of Saturn's rings. In 1990, the Cassini-Huygens spacecraft was born. It's one of the most ambitious missions ever to our outer solar system. The mission came in 2 parts. The Cassini orbiter, built by NASA, will take the most close-up images of Saturn's rings. Traveling with the orbiter is the Huygens probe, designed by the European Space Agency. This will touch down on Titan, the first probe to land anywhere in the outer solar system. Professor John Zarnecki of the UK's Open University is one of the lead scientists on the Huygens probe.
Titan is halfway across our solar system. So we really were, I would say, even a little bit crazy ever to take this on.
Another member of the team has been waiting 20 years to see below the orange clouds of Titan. Professor Jonathan Lenine of the University of Arizona.
To completely understand Titan, to see what was underneath this interesting organic-rich atmosphere, it was necessary to send a probe and an orbiter.
For the design team, creating a probe for Titan is a prodigious challenge. Titan's atmosphere is so thick that we cannot see through it to the surface. Prior to landing there, we cannot even be sure what Titan is made of. Professor Zarnecki and his team design a small spike that would penetrate the mysterious surface on landing. The spike is the very first instrument to touch the surface of Titan. It sends its data back to Earth for analysis. In the laboratory, scientists compare the electrical signature of different surfaces, some soft, some hard, giving them a wealth of data.
We didn't know if it was solid or liquid. It was that bad, our understanding or our knowledge of the surface. We had no idea if we'd float on liquid methane or we'd thud down onto a hard, icy surface.
On October 15th, 1997, after 7 years in construction, the Cassini-Huygens probe is ready for launch. The spacecraft is enormous, the size of a school bus. At the time, it took the largest rocket in NASA's arsenal, the huge Titan 4B Centaur launch vehicle, to send the probe into space. The rocket weighs 1,000 tons. It's the height of a 22-story building, and at 4:43 in the morning, the final countdown begins.
T-minus 10.
Across the world, 8,000 engineers and technicians hold their collective breath.
About 12 minutes.
The previous launch of a European space mission called Cluster saw the rocket explode shortly after takeoff, destroying the $500 million spacecraft and shattering the dreams of hundreds of scientists. All the team can do is watch and pray. Professor Marty Tomasco of the University of Arizona built the camera that would take the first pictures of Titan's surface.
It was only about the fourth launch of a Titan IV for a civil space mission, and I believe the launch before us blew up on the pad.
I was such a basket case during the Cassini launch. Many people have lost spacecraft, payloads, work because the rocket blows up.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
Right on time, the rocket takes off.
Its program is in, roll program is in.
The launch goes without a hitch.
We have cleared
The rocket rises high above the platform.
Is on its way to
Cassini's perilous 7-year journey to Saturn has begun.
Turn is speed separation.
The spacecraft uses the gravitational pull from Venus, Earth, and from Jupiter to gain enough momentum to reach Saturn. When the probe approaches a planet, the gravity of that large body takes over, propelling it past, this time faster. Engineer on flight operations on the Cassini-Huygens mission is David Duty.
When a spacecraft flies by Jupiter to get a gravity assist, it's taking some of Jupiter's momentum to speed up the spacecraft.
But along the way, there are many dangers.
There's always the chance of micrometeoroids, small dust particle grains of sand, which of course are traveling at thousands of miles an hour.
The next obstacle is the beautiful but deadly rings of Saturn. This is the largest space probe ever built. Now it must make it through an area littered with rock and ice to Saturn's moon, Titan. The Cassini-Huygens space probe is on a 7-year journey to Saturn. If all goes to plan, Huygens will be the first probe ever to land on a body in the outer solar system. For the mission to succeed, the Huygens probe must send its data from the surface of Titan back to the orbiting mothership, Cassini. Cassini will then relay the information to Earth. Before the fixed communications system can prove its worth, Cassini and Huygens have to overcome one last deadly obstacle: Saturn's rings looming on its horizon. These rings are made up of billions of pieces of rock and chunks of ice, from the size of a dust grain to the size of a house. Saturn is 95 times as massive as Earth, and its enormous gravitational field captures any passing objects into its orbit to form the rings. These rings are wide, nearly 165,000 miles, but very thin, only about half a mile of beautiful but deadly rock and ice. To reach Titan, Cassini-Huygens will have to fly right through the gap between the 5th and 6th, or F and G rings, using its main antenna as a shield. One miscalculation, and the huge probe will smash into 1,000,000 pieces. June 30th, 2004. Cassini prepares to enter orbit. Millions of dollars and entire professional careers are on the line. Mission Control waits for a signal that the probe is still intact and operating. Cassini rotates its giant antenna and heads toward the gap. Mission Control waits nervously for the signal that the 6-ton, $3 billion spacecraft has survived. 19 minutes later, a signal comes through.
Johnson just reported a signal. We've survived the ring plane crossing through the F and G ring.
The probe has survived, though not completely unscathed.
The Cassini spacecraft was hit about 500,000 times as it went through the ring plane at that point. Fortunately, all of the hits were of tiny particles the size of smoke particles.
Despite the hits, the probe is still functioning. It's time for Cassini to release Huygens for its mission to Titan. On January 14th, 2005, Huygens enters the thick, foggy atmosphere. On board, a camera is set to take the first ever pictures of this mysterious moon.
This literally was the culmination of, for many of us, more than 15 years of work. It was success or failure in a matter of just a few hours.
I had had nightmares for many years that this just wouldn't work and we would not get a single piece of data from Huygens.
Unlike the Mars landers with their airbags, the Huygens probe has only parachutes to slow down its fall. There are 3 of them, and they should give the probe time to take the first pictures of Titan from below the clouds. But danger heightens as re-entry and touchdown approach. It will be 4 hours before Huygens can contact Cassini to confirm it is safely on the surface. Until then, the team can only hope for the best. But unexpectedly, one of the telescopes tracking Cassini picks up a signal direct from Huygens itself, just an hour after the probe has landed. 3 hours before Cassini can relay the signal to Mission Control. The signal is incredibly faint, but proof that Huygens is alive and well on the surface of Titan.
The strength of the signal received on the Earth from Huygens was unbelievably small. I think it's something like the equivalent to putting a mobile phone on the surface of the moon.
Huygens was alive and transmitting directly back from Titan, the first probe to land on a celestial body in the outer solar system. Huygens has survived the landing, but the real data signal is still to come.
I'd been preparing for this for many years, and I think because one always knew that it might fail, we might receive no data, I'd sort of prepared some sort of emotional barrier in case it didn't work.
3 hours later, and 7 nail-biting minutes after Cassini was supposed to transmit, Mission Control begins receiving data back from Saturn's most extraordinary moon.
Here, for about 2 minutes, were these thumbnail images of Titan's surface, the first that any human eye had seen of the surface of Titan, coming at you, one every second. And so it was this incredible emotional experience, and people were screaming as these pictures came through for about 2 minutes.
The first pictures through are of Huygens' descent. The landscape looks similar to parts of our own planet. The camera has less resolution than a modern cell phone, yet the images are detailed enough to show a rocky landscape, but with a difference.
We're pretty certain that it's the equivalent of sand or gravel. But in the case of Titan, the sand and gravel is not made of rocky material, stony material like it is on the Earth. The bedrock on Titan is ice.
Back in space, Cassini's special infrared cameras reveal that Titan's surface has undergone geological processes similar to those on Earth, lava flows, and even volcanoes. Cassini is set to continue gathering data until at least 2008. In that time, scientists are confident they will learn new and extraordinary things about this strange world, teaching us more about the chemicals that gave rise to life here on Earth almost 4 billion years ago. Both Mars and Titan are helping us to build an even more complete picture of how our solar system formed in the first place. And there's more to come. NASA is studying future missions to Mars, including the possibility of collecting samples and returning them to Earth. There is even an idea to send an airship-style probe back to Titan to travel through its atmosphere, gathering data. Probes such as Cassini-Huygens, Spirit, and Opportunity are the pinnacle of human technical achievement. Through them, we have learned secrets that would otherwise have remained mysteries forever. And where probes go today, perhaps people will go tomorrow.
One of the things that we're doing, I hope, with this mission is exploring the next generation of scientists and engineers who are going to go to Mars and do stuff better than we were able to do it. Okay, because they saw this on television, because they saw these pictures on the internet, and they thought, hey, that's neat. I bet I could do this. I bet I could do this better.
Wherever future generations may go, whatever they may achieve, one thing is certain. Probes will go ahead of them, revealing new knowledge and new mysteries. And perhaps one day, there will even be a probe that delivers the ultimate news. We are not alone.